Hi, this is Katie Porter. I'm just going to be explaining the neural impulse today through video. So to begin, I'll kind of give a brief overview of how I have it set up. Here's your neuron. I've got the dendrites, the nucleus, and the cell body. Here's your axon hillock. Down through here is the axon. We've got the nodes of Ranvier, your Schwann cells, your axon, and the synaptic knobs here in the axon terminal. So first, this neuron currently is in resting potential of negative 70 millivolts. It is inactive and polarized. And polarized means that the electrical charge that's on the outside of the membrane is positive, and then the electrical charge on the inside is negative. So right now it remains this way until the stimulus of this impulse arrives. The sodium ions are right here. They're on the outside of the cell, and the potassium is here located on the inside. So first, when a stimulus reaches a resting neuron, the all-nothing reaction occurs. This just basically means that the neuron either chooses to take the action, to take the impulse, or to not take it completely. It's kind of like a go big or go home kind of aspect. So first, the impulse comes in to the neuron, travels through the axon hillock, and reaches the axon. Here, the gated ion channels on the membrane open, allowing the sodium here to travel to the inside of the cell. As this happens, the neuron becomes depolarized. Each neuron has a threshold level of negative 55 millivolts, and after the stimulus goes above this level, more ion channels open and allow more sodium to travel inside of the cell. This causes depolarization of the neuron, as stated before. The action potential is now created. And also in this moment, potassium ions then also move out of the cell. As sodium comes in, potassium moves out. This is repolarization. After the inside is now fully enclosed of sodium, potassium moves out, and the repolarization restores the balance of the neuron. It is opposite of the polarization balance that we had prior, because now, like I said, the sodium is on the outside the sodium is on the inside and potassium is on the outside. Just after the potassium gates open, the sodium gates close. Because of this, the membrane of the neuron can no longer repolarize. We actually talked about that in one of our discussion boards, or voice threads, I believe. Once these potassium gates finally enclose, the neuron has just a little bit more potassium on the outside than it does on the inside. This means that the membrane potential is lower than the resting potential of negative 70 millivolts. This is now when the membrane is hyperpolarized due to its greater potential. Now we have entered the refractory period. It's when all the ions are returned to their normal places. Sodium is moved out and potassium is moved in. This is done by the sodium-potassium pump. It allows 3 sodium out at once and 2 potassium in. So I will go ahead and move those over for you. Oh, yeah, there we go. And this neuron will then stay in that resting potential because now it is back to where it was. This impulse has already done traveled through here, and I will get to this part of it in just a second. But yes, this part of it, of the impulse, is now completed. It is back into its resting potential of negative 70 millivolts until just another impulse comes along and restarts the whole process. Now we'll get over into this part of what I have made, just showing kind of like the synapse of one of these synaptic knobs with another I lost my words. Sorry, with another neuron. So we have, this is the presynaptic knob. This is this right here, just kind of blown up for visual aspects. We've got the axon coming through, and then this is the knob. Right here, I've got the voltage gated calcium channels with a calcium ion on the outside of in the synaptic cleft. This is the whole synapse, and the cleft is right here between the two neurons. These right here are the neurotransmitters, and this is just the postsynaptic neuron. It could be the cell body or the dendrite, as I have right here, of just another neuron. In this moment, the impulse that traveled through here comes to this point. Neurotransmitters that were inside, probably should have put them on right here. The neurotransmitters on the inside of the neuron reach the vesicles right here, the synaptic vesicles right here, and they release the neurotransmitters. Calcium enters through the cell at this point as well, or into the neuron at this point as well. The neurotransmitters then travel through the synaptic cleft until they reach the next neuron. And at this point, the action potential is finally completed. The impulse has traveled all the way through and reached the postsynaptic receptors for the neurotransmitters. I know my type of explanation is kind of everywhere. I just kind of went with my own kind of thing here and made my little extra visual for you. I hope it was well for you. Thank you.